Good morning. Welcome to the Design and Analysis of Algorithms Laboratory Program Explanation. Today we will see design and the aim of the program, lab program 3A. The aim of the lab program is to now write a Java program to read two integers a and b, compute a by b and print the result when b is not 0. Otherwise, there is an exception when b is equal to 0. The main task of this program is just to write two integers a and b, compute the division operation a by b and print the result when b is not 0. Otherwise, there is an exception when b is equal to 0. Before we go to the design of the program, let us now see what is basically an exception. An exception, very simple. It is a runtime error which has been generated during the execution of the program. These runtime errors, when they are generated, will cause the program to abnormally terminate without allowing the program execution to be continued. So there are different types of runtime errors that can happen when we are executing the program. Let us look some of the runtime errors that might occur during some of the errors and the typical causes for the errors to occur are as follows. Memory errors, that is memory incorrectly been located, memory leak, accessing a null pointer, file system errors which might cause due to the disk is full, the disk has been removed, network errors which may cause to network is drawn, URL does not exist, or calculation errors which might deal with something called as divide by zero. The program which we are now dealing is with respect to calculation errors, that is divide by zero. Some of the other causes of errors are something like array errors, accessing an element which is not present in the array, or accessing an element to the index which is not present in the array, conversion errors, converting a character queue to a number. So you can also think of some others which can also cause the runtime errors. Now these runtime errors which are being caused, which we also called as exceptions, and as we know, whenever these exceptions have been generated, the program automatically terminates the execution wherever, at whichever point it has been. That means the generation of the exception allows us to now terminate the program abnormally. So in order to handle these exceptions, there should be some mechanism wherein the user will get the appropriate message that there is an exception raised and continues with the program execution. So that has been achieved by something called as exception handling through a mechanism called as try and catch mechanism. So what is this try and catch mechanism? It's one of the way where we can handle the exceptions which avoids the program to terminate abnormally whenever an exception is occurred. So how do we write this try, or how do we use this try catch mechanism? So whenever you feel that your code may trigger an exception, just include that code or include the code logic inside a block of code starting with the keyword try. After the try block, the code to handle the exception, should it arise, is placed in a block of a code starting with the catch keyword. That means to say any code that may or may not raise an exception, just include in the block starting with the try keyword. Once the try block is written, we will have to also write the code to handle the exception if it is raised. It has been achieved by using something called as a catch block, which has been started with the catch keyword. So we are supposed to now write the try and the catch block. So when we are writing a try and a catch block, we can write a single try block and write multiple catch blocks. When we talk about catch blocks, multiple catch blocks or a catch block, we can tell there are two types of catch blocks, that is generalized catch block, the other one is the specialized catch block. So as the name indicates, specialized catch block tells that the catch block can access or can handle a specialized exception, whereas a generalized catch block can handle any exception irrespective of whatever kind is that has been generated within the try block. Along with this try and catch mechanism, we can also include one more block called as finally block. This block contains the code that has always been executed whether exception is raised by the try block or not. So usually this finally block is usually written after the catch block code or either the try block code. So the example for writing the try and catch block is as follows. Use the keyword try. The code that may generate an exception should be included within the try block. Then end the try block. Next is write the catch block, which takes a single argument. And wherein, what is that single argument? Where E is an object of the exception class. If at all we are writing any generalized exception, then we write the class name as exception because E is an object of the class here, exception. In case if it is a specialized exception, then we will have to write the class to which the exception is being considered. Suppose say if we want to consider divide by zero exception, then we need to write the class here as arithmetic exception. And then write the code which is now handling the exception. So the flow of the program goes like this. If at all in the try block, if there is any exception raised, then automatically the control moves to the catch block, executes or handles the exception in the catch block, and then continues with the normal execution of the program till the end. Now we'll see the program design, wherein I'll just include the statement, include statement, scanner, create it as a class, exception divide, name as exception divide, main function, public static void main string args. Then created an object, input device, which is an object of the scanner class in order to read the numbers a and b, two integer numbers, for a and b from the user. Scanner input device is equal to new scanner system.in. Read the first number, which is the numerator, from the user and storing it in the variable a, and also reading the second number, which is the denominator, and storing it in the variable b. As we know that the division operation is computing a by b leads to an exception when b is equal to 0. So we know that the computation statement will now tries to lead to an exception. Therefore, we will just introduce that computation statement within the block try. Within the try block, I'll just write computation statement, that is float result is equal to a by b, wherein it computes a and b and stores the result or stores the quotient value in the result variable. And once it is computed, we need to also print the result, system.out.println division result of a by b is equal to the result value. End the try block. That's all about the code which is inside the try block. Wherein this try block, in case if there is an error occurring or an exception occurring, which is divided by zero exception, it should be immediately caught by a catch block. So we'll have to now design the catch block using the keyword catch and object, which has a single argument which holds the object of the class exception. So it is an object of the class exception. So how do I handle this exception? I'm just printing a message here, system.out.println exception condition handled. Wherein without this try and the catch block, if at all the program was executed and then value for D get by the user was 0, then the program would have been abnormally terminated rather than terminating the program normally. But using try and a catch block, now a program terminates normally as doesn't go for abnormal termination. So I have also included one statement after the catch block, that is system.out.println program ends, and then end the main function, and then the main class definition. So when I execute this program, so there are two possibilities of outputs. One possibility where an exception is raised when we compute the division operation, or an exception is not raised. So for example, so I now read two numbers. First number is 10 by 10 and 2. So when first number is 10 and second number is 2, there is no concept of raising an exception. So result is equal to a by b 10 by 2. Print the result as 5.0. It enters the try block and finds that it does not raise an exception. Henceforth, it ignores the execution of the catch block. The catch block is now not executed, then jumps to the next line after the catch block where it tells it is program ends. The output looks something like this. Enter the first number, second number, the result is so and so and the program ends. Output 2 when there is an exception, that is the second number is entered to be as a 0. Suppose say first number is 10, second number is 0. The control enters the try block, finds that the second number is 0, henceforth an exception is raised. So the control stopped its execution when an exception is raised in the try block and jumps to the catch block. So in the catch block, the exception will be caught, and I will execute the code within the catch block which prints a message so far as the exception condition handled, and the remaining program execution will be normal till the end of the program. System.out.println program ends. This is the output of the second case where an exception is raised. So it finds that an exception is raised in the try block, it immediately jumps to the catch block, and the remaining statements below the catch block will be executed till the program ends. This is the output of the second case where an exception is raised. This is how the program design is made to handle the exception here. Thank you.